Hope you get refreshed by your coffee, tea, whatever. Uh, I titled this conversation Pipeline Your Pipelines, and this will be soon clear what I mean with this. A word to the organization and the sponsor, thanks them. Thanks for the invite. I always love to be at the DevOps Days conference because they are amazing in many ways. So, a couple of words about myself. My name is Giulio Vian. I work in the Dublin building studio of Wipro Digital. We focus on digital transformation and these kind of things. Okay, you can see my hair is starting to get gray. I work with primitive computers, worked for a number of companies. I've got some kind of affiliation with Microsoft, having worked there for so many years. But I still love to do community stuff. Okay, we have some communities in Italy here, and I love to be at this kind of conferences. Regarding this session, it will be at an introductory level, so no code, sorry. But there is code for anyone that is interested into. There is a GitHub repository. I blogged about this topic in a series of blog posts. They are unfinished, so I need to complete them, but they will be out sooner than later. As usual, the deck will be available on SlideShare. All the links will be at the end of the session. My thesis is that there is no such thing as a development environment. Everything is production. Well, maybe you may think this is a bit extreme, but you will get very soon what I mean. I tell you a story, and I was working at that time in Glass Lewis, and what I realized was that the great part of our build was running on a poor single physical server. It was a great machine, a lot of memory, a lot of cores, fast disk, fantastic, but only one. And over the years, there were a lot of software installed that was really messy. Literally, I had no idea what was really required for our builds and what was not. So this was kind of those things that you really need to solve whenever you get time. So it's really scary, sorry, to have a single machine you depend on. What happens if I lose it? I don't even have the inventory of the software that is installed on this machine. All right. So let's start to think about what happens if I lose it. It's not just that I cannot build. Now we automated more and more all of our pipelines. So we don't have just build pipelines. We have deployment pipelines. We have CD. And CD requires that you have CI working. And if you don't have everything working, you need to go back to manual work to deploy in production. But manual work means you are building on an untrusted machine. You don't know what libraries are there. You are hard time in running all your static checks, your security tools. You are not running your unit. You're missing a lot of stuff which you have in your pipeline. And so, without all those automation, you are not able to go to production anymore. So, if you lose your build infrastructure, you're kind of busted. The more you automate, the more this becomes important. So, we got to the first of the three principles that I hope you will agree with me, which is development is production. So if it's not the user production, it's the developer production. All right. Yeah, there is a funny joke here. You can download the deck and look at that. It's very true, that every environment is being built in a very fancy way. But I'm a fan of infrastructure as code and these similar ideas. For people who are not familiar with CI/CD infrastructure, here is a small recap. Usually you have something that I call an orchestration server, the build server, and you have a number of agents running on other machines, often also called build servers. The orchestrator will instruct the agent to run the stuff, and the build server is hosting your tool chain, which I intend the compilers, static checkers, testing frameworks, whatever you need to execute your pipelines. Usually the outcome is going to the artifact store. There is a problem with terminology. Nobody cares about having standardized this terminology. So agent is something that people use, but other people use a different word. And in fact, you can see, for example, in the Jenkins jargon, you have a master for the orchestration server and slave for the agent. GitLab use node and runner, so on and so forth. Agent is kind of the most common usage, but not the only one. Okay. Now we are all settled on a common vocabulary. In addition, you have continuous delivery, which is a similar architecture more often than not. You have some kind of an orchestrator server that can drive one or more agents, and the agents can run on the target machine itself or do remote work on a target machine. Clearly, a scenario could be you have the orchestrator with the agent running on the same machine and you are deploying to the cloud. Fine. This scheme applies too. The conjunction point between CI and CD is the artifact store, which is what should be the best practice in decoupling the two subsystems. Sometimes you have the same orchestrator server that is built controlling both the CI and the CD pipelines. Sometimes you have two different systems. So, for example, you can have Jenkins for the CI. You can have something like Octopus Deploy for your CD, or Spinnaker for your CD, and so on and so forth. Up to you. Artifact store could be an artifact store like Nexus, could be a Docker registry, all those kind of stores. So, I'm talking about managing this infrastructure, but I can solve everything by just going and using a build as a service. Say, I just rent Circle CI or Upveyor or one of those services and use their agents, their server, and whatever. There is only one thing that kind of blocked from the security perspective, and it's about sharing secrets. Because sometimes in the build, I mean the CI pipelines, but very often in the CD pipelines, you need a lot of information, a lot of secrets that is very, very sensitive. So this second principle that I hope you agree, I prefer to have this thing in an environment that I strictly control and manage, kind of limited trust to multi-tenancy, all right? So typical secrets are password to databases, SSH keys, SSL certificates, and so on and so forth. For example, code signing certificates are required at the CI stage. So, for example, when you need to deliver a package for the desktop or the mobile, must be signed, and so on. And those are your identity. It's very sensitive. If those secrets get lost, you are in big trouble. You need to retire them, and it's a real mess. So we analyzed what we were using in our CI/CD, what was the important pieces, what was the kind of less important pieces, to understand what was really disposable, what was critical. And so we end up with this kind of scale. At one extreme, we have the build infrastructure, which is completely disposable. Ideally, I can use a new agent, a new build server for each execution of a build pipeline. Okay, a new CI is running on a new server. On the other extreme, you have the source code, and this is the most precious thing you have. You don't want to throw that away. and you have intermediate stuff. If you lose your testing data, it's not nice, but you can survive. You can move on. If you lose your keys, it's a problem, but you often have ways of renovating your keys, producing new keys, and so on and so forth. So, for example, keys are not a persistent thing. Think about the SSL certificates. They will last at most 2-3 years. They cannot last longer. So you have to refresh them anyway. So we got to the third principle, and it's automate everything. So what we did is, okay, we have all this infrastructure, and we want to create infrastructure for our infrastructure. So we ended up with 2 designs. The first design is, okay, very simple, very basic, easy to apply on-premise, easy to apply on the cloud. The idea is that, okay, you have some bootstrap mechanism, you create the initial orchestrator server with an agent, and then you have a number of hosts that are hosting your build and deployment pipelines. The host will have an agent, okay, so can run pipelines on the host, and you have nothing else there. So on the host, you have just the bare minimum things. Everything else is run inside the container. So the host will have the Docker daemon running, and you don't need anything else. The container will need a Docker register, and this is the other piece of the puzzle. There is another option, which is to use Kubernetes. I don't go there in how easy it is to set up a Kubernetes on premises. I'll leave this to other speakers. Usually it's much, much easier to have this in the cloud, and is more a cloudy design. Okay. First of all, you need some bootstrapping. Okay, so you need a bare minimum build server that can run your pipelines. And that is, you can script them very easily, usually. For example, nowadays you have Jenkins that is running inside a Docker container, so you need at least a machine with the operating system and Docker, and you can start working from there. Eventually, you restore the backups from the previous instance of your orchestration server. The second step is the hosts, the hosts that are holding your pipelines, and they can be physical machine, virtual machine, Kubernetes cluster, and so on. You have tons of tools. This is kind of the infrastructure as code 101. You have multiple options. You can, for example, use stuff Metal as a service to imagine your physical machine from a well-known image, which is still very basic. You don't need a lot of stuff there. You just need the operating system and the agent, the meta agent, and the Docker daemon to host the Docker containers. The second step, this is more interesting, and it's often distributed between the various development teams, because each development team is using a set of tool chains. There is one team that is a .NET team, and so they are using .NET Framework for 7. There is another team that is using Java 8. And usually you don't need a single build server with all those things together, so you can just have a Docker container with a specific tool chain plus the agent. Clearly, in addition to the compiler, you will need to install everything else that is needed for your pipelines. Could be static checkers, testing framework, whatever you need. Clearly, you have the ownership of these Docker files. You instruct what you have there, and you need to refresh them frequently with the latest patches, so you have everything secure and so on. A nice side effect of having your build running in containers is that you guarantee that your builds are stateless, which is problem I found in a few environments. You're using and reusing the same machines, the physical or virtual. There is stuff laying there. Shared objects, DLLs, files are there, and nobody realized until you move the build to a different machine that there were physical present there and they are not in source control or coming from other things. So there is a nice side effect that the builds are stateless, and it's a great improvement. Oh, now we got to the fun part, which is the title of the talk. You can have a pipeline that is running all the agents running on the host, which is using Docker to instantiate containers. Clearly, you need a Docker registry for that. You pull them down, and you kick off containers. One problem you find here could be some build systems. One notable is Bamboo, Atlassian Bamboo. You need a manual step to enable the agent. Okay, while other systems, Jenkins or Azure DevOps, you just need a key to register the agent with the server. Other systems, you need an administrator going manually there and enable the agent. Clearly, this scenario works well for a limited number of machines. You can also pipeline the creation of the host. So in the Bootstrap, you have the server with an initial agent, and if you have enough of the cloud stuff, you can imagine to create your host in the cloud. That's one option. Or if you have another stuff like VMware or Hyper-V, you can run a script and create your hosts that are with the Docker and everything else. The host can be of different types. Everyone thinks about Linux, but nowadays you can have also Windows containers running on Windows Server 2019, and it's a nice option for a kind of Windows build. Someone is still building Visual Basic 6. It's a reality. Okay, we have these things. So let's be real and enjoy the fact that we can finally containerize Windows code. Clearly, you can go with Kubernetes and not bothering managing machine. You still need the bootstrapping of setting up the cluster. This is kind of the most simple thing to do. If you see my post, there is a lot less code to manage, but it's an interesting thing. A couple of interesting benefits of adopting this approach is that by scripting everything, by having pipelines that are creating your build agents, your host machine, and so on and so forth, you have an exact definition of what is needed for your build. The version of the tools in the chain, the version of the operating system, and so on and so forth. So it's self-document, like all infrastructure as code techniques. Can be easily recreated with cloud providers. Docker is easily portable from one to the other. You can run on-premise also, and so on and so forth. I suggest also that if you are running on-premise, okay, and you never used, if you never used anything like Docker, this could be a nice way to have your development teams starting to learn Docker approaching, because they are not doing this for production code. They are not doing this for touch. You're not requiring your operation to have Docker in production. So it's kind of swift spot, safe place where they can play and learn. So that's another thing to consider. The last critical thing about your CI/CD infrastructure, you need a backup of it, and I recommend to print out in a physical paper the Bootstrap instruction. Okay, so how to restore your backups? Okay, because it could be that your wiki is part of your build infrastructure. Oh, it's down, we don't have the wiki. Okay, consider this. Keep this in mind. About monitoring, okay, you can also add monitoring to your CI/CD, which is a good thing to do. Usually some very basic stuff is all you need, because if the builds are queued and they are not running, someone will scream soon. Much faster than your user. Okay, developers are kind of very, very loud in this respect. So, going to the end, the more you automate, the more everything becomes production. Means your CI/CD, it's not just a developer tool. It's an operation tool. You need to treat it with care and love, just like you do for everything else you have in production. Because it will be your way to deliver code to your users. As I touched in the beginning, I wrote this down in a serious post. Those exemplify the thing with the Azure pipelines. Forgive me, okay. There is no Jenkins examples, okay. But the principle can easily apply to in other places. The Docker code, the Kubernetes code, that is absolutely fine, will work everywhere. It's unfinished, so I have the code, but I need to finish up a couple of episodes of this thing. The usual links, the blog posts are tagged. They are also duplicated on Medium. There is the GitHub repository on my account. My account in SlideShare will hold the... it's already published, I think, this deck. You can contact me as much as you want. So if you have questions offline and ideas, share, exchange, I'm always available. And this is the end of my presentation. So we have another 5 minutes or so, or you can run to lunch if you're hungry. If you have questions, I'm here for you. Yep.
So if anyone has any questions.
Thanks.
Thank you very much. If anyone has any questions, anyone? Or is it just me?
Yeah, if you have.
Easier to try that again, sure?
There is nothing wrong with VB6. Well, I can say something on the change that happened between VB3 and VB4. Okay. Because from a statically typed language, they blur the line in a dynamic typing language, and I'm still suffering from that. Okay, VB6 is you still have the runtime of Windows 10, and on the latest Windows Server 2019, so it's still around. Okay, and there is still people working with VB6 today. Like it is people working with COBOL. It's a perfectly fine environment and language. There are very sweet spots. And really, sometimes I have this desire that web developer had some experience with VB6. Because it kind of pushed you to have some rules. There were a lot of guidelines how to design the user interface. The tool was designed by Cooper. You know who Cooper is. So it was an amazing tool in many respects. Really created a lot of new ideas. Yeah, and we are reinventing the wheel every now and then.
Any other questions? Okay. I think we're good.
Yep. Free for
Thank
lunch.
you very much. Thank you.
Yep. Thanks.